Hi, good morning. This is Trina here to discuss about oxidation and reduction reaction. It is the part of organic reactions. And in my personal information, my contact number and email ID is given. So if you have any doubt, you can communicate with me. And here, the most important part is given, that is the course page. So here all the study materials are uploaded. And not only that, the questions, probable questions, the semester questions, and the solved problems also given here. So first of all, you need to join with the code given here, that is DMBC. Then you can avail all the study material. Here the subject is chemistry and the subject code CH101 for odd semester, CH201 for even semester. This course is for undergraduate BTech students and the streams are CSE IT Civil Mechanical for even semester and the Electrical EC BME for odd semester. And the credits are 3, contact hours 35. So weekly I will take 3 classes, 3 lectures. And the prerequisites knowledge required to understand this concept is 12 standard. So about the course objective, the students will learn the different concepts of chemistry from these chapters. And here the course outcomes, you will learn the organic molecules using different reactions. You will learn different reactions of the organic chemistry. And also the lesson plan is given here. So in the lecture plan, you will get the which topics will be covered in which day. So first it is the module 1, then module 2, and our part is in module 3. So module 3, that is organic reactions. And you have already learned the first 3 lectures. I have covered these first 3 lectures, the concept of inductive effect, this one, then introduction to reactions involving substitution, and also you have learned the addition and elimination reactions. So today you will learn the oxidations, mainly the Baeyer-Villiger oxidation, and the reduction, that is the Clemmensen reduction and Wolff-Kishner reduction. So this part you will learn today. Okay, so this part. Number 4. And also the textbook of organic chemistry available in the library, you can also collect it. So first of all, you need to know what is oxidation and what is reduction. So already you know what is oxidation, what is reduction, that is very common. You already learned in your HS standard. So in reference to organic molecules, oxidation is a process by which a carbon atom gains bonds to more electronegative elements, most commonly oxygen. So oxidation means the gain of oxygen. And reduction is a process by which carbon atom gain bonds to less electronegative elements, most commonly hydrogen. So here you can see that in the oxidation part, the alcohol will be converted into the aldehyde. Then it will be converted into acids. And here the example also given, like it is the alcohol. and you get here the group that is the OH, and aldehyde that is the CHO. This group is the CHO, that is the aldehyde group. And then we are getting the carboxylic acid, COOH, that is the carboxylic acid. Okay, so if we want to convert by oxidation process, like from alcohol then to aldehyde to acid, so there will be required some oxidizing reagent. And there are different types of oxidizing reagent: weak oxidizing reagent or strong oxidizing reagent. So if we want to convert directly from the aldehyde to acid, okay, so we require the strong oxidizing reagents. But if we use the weak oxidizing reagent, then first it will become alcohol to aldehyde, then aldehyde to acid. So in this way, the steps will take place. So here you can see the other example of the oxidation, that is the ethanol to acetaldehyde. Okay, it is also alcohol to aldehyde. There are lots of more examples. You can see the chart, that is the oxidation and reduction. So from upper side to lower side, it is the arrow is given, that is the oxidation. And if we move the upward direction, that is the reduction. So this part, it is the oxidation, you can see the arrow, and this one in this direction is the reduction. So opposite of the oxidation, that is the reduction. That means like alkane to alcohol to alkyne, then aldehyde or ketones, these are the oxidation. If I tell that like ketone to alkane or ketone to alcohol, that is the part of reduction, that is just reverse. Okay, so you can understand that, like say alcohol, this is the alcohol to say aldehyde or ketone, that is the part of oxidation. Okay, so if we move from the alcohol to ketone, that is the oxidation. If we move to ketone to alcohol, that is the reduction. So here is given different examples. So oxidation, reduction, that is just the reverse process. Now I will show you different oxidation reactions with the different oxidizing agent. So first, in organic chemistry, the gain of oxygen or loss of hydrogen is often referred to as oxidation. So PCC, it is the pyridinium chlorochromate, that is the oxidizing reagent. Is other efficient reagent which widely for oxidation of primary and secondary alcohol. And here is DCM. DCM, the full form is dichloromethane. The formula CH2Cl2. So here you can see that when we use the PCC and DCM here, then it is the alcohol OH and it becomes oxidized CHO, aldehyde. Okay, and you look here, the carbon, this double bond, all this part remains similar. Only the alcohol part becomes the aldehyde. Next, here also the example given, the alcohol, then PCC in presence of PCC, dry CHCl3, anhydrous ACOH, then we are getting the aldehyde. Okay, so you can understand with the presence of oxidizing reagent, the alcohol is converted into aldehyde. Another similar oxidant is PDC. It is pyridinium dichromate. Okay, this one is pyridinium dichromate. So, what we are getting here also, we are getting the alcohol to aldehyde, the 90% aldehyde. It is the pyridinium dichromate. PDC is less acidic than PCC. So it is often used to oxidize alcohol that may be sensitive to acids. Next, another oxidizing reagent like the Jones reagent. Here you are getting the Jones reagent. It contains the chromium oxide, sulfuric acid and acetone. It is the CrO3, that is the chromium oxide, and this is the H2SO4, and there is the acetone. Is used for the oxidation of primary and secondary alcohols to carboxylic acid. So here from the alcohol we are getting directly the acid COOH group. Here is the COOH group. Okay, so we have learned to convert the alcohol to the aldehyde and also the alcohol to acid. Now, another example also given here, you can see that is with the similar Jones reagent, the chromium oxide, sulfuric acid and acetone is given here. Okay, it is the similar part, the Jones reagent, and here is the alcohol and it is the conversion. Now, manganese can function as oxidant when it is +7. So you know that manganese has different oxidation state. So when it is like +7, that means in KMnO4. KMnO4 it is +7, but say MnO2 that is +4. So here +7 oxidation state that occurs when it is present in the KMnO4 then is one of the oxidant. It is very strong oxidizing reagent. You know very well about the KMnO4. And KMnO4 is also used to oxidize primary alcohol and aldehyde to corresponding carboxylic acid. You know different oxidizing reagent like K2Cr2O7. Other than KMnO4, we also can use it. So what will it convert? Alcohol and aldehyde to corresponding carboxylic acid. So it is like oxidize the primary alcohol and aldehyde to corresponding carboxylic acid. So now let's look at the example. So the examples given here, you can see the figure, okay. So all this case you can see either the alcohol or the aldehyde with the help of KMnO4, we are getting the carboxylic acid. So how you can understand these are carboxylic acid? Because all here there is COOH group. Here is also COOH group. So these are the carboxylic acid. Here is COOH group and also COOH group. So in this way, if we use the different oxidizing reagent, then we can convert the alcohol or alcohol into aldehyde or acids. Next, so here you have got lots of example with the KMnO4. Now come to the oxidation that is called Beer-Villiger oxidation. So what is it? So the Beer-Villiger oxidation is an organic reaction used to convert a ketone to ester using a peroxy acid such as MCPBA. MCPBA, the full form is meta-chloroperoxybenzoic acid. Meta-chloroperoxybenzoic acid. Okay, so with the presence of this one, MCPBA, meta-chloroperoxybenzoic acid, the reaction of the ketone with the acid results in a tetrahedral intermediate. Okay, with the alkyl, look here, alkyl migration following a release of carboxylic acid. The more electron-rich R group migrates to the oxygen in the concerted process, allowing for accurate prediction of the stereochemistry of the product. So here you can see the reaction. Okay, here it is conversion of ketone to ester. CO to COOR, ketone to ester. So ultimately we are getting from ketone the CO to the COOR to the ester. Okay, so you have understood the Beer-Villiger oxidation. So with the presence of, we use, that means conversion of ketone to an ester using MCPBA. Okay, that is called Beer-Villiger oxidation. So here we are getting the product. Now, come to the next part, that is reduction reaction. So you have learned the oxidation reaction, the reverse of the oxidation reaction, that is the reduction reaction. So here in organic chemistry, the loss of oxygen or gain of hydrogen is often referred to as reduction. The aldehydes and ketones are reduced to give the corresponding alcohols when treated with lithium aluminium hydride, LiAlH4. For the reduction of aldehyde and ketones, the reaction is generally performed in other solvents at low temperature. The acids are often reduced with LH to prepare the corresponding alcohol. The other comparable method for reduction of acid is using BH3 as a reducing agent. The 3 hydride ions are consumed for reducing one acid group. Okay, so look carefully. You got different oxidizing agent. Similar way, you will get different reducing agent. So here you are getting first, like say one is LiAlH4. So I am marking this one LiAlH4. Also the reducing agent, you can use the BH3. Also the weak reducing agent, you can use the sodium borohydrate. We will get it later also. So look at the, so it is the just reverse of the oxidation. Like oxidation, we converted the like alkene to aldehyde to ketone and ketone to ester like this. So it is just a reverse process, like the reduction of aldehyde and ketone we will do here, and we will get the like alkene, etc., or alcohol. So here you can see it is the carboxylic group COOH acid, and we are getting the alcohol COH. Okay, And here is also given, that is also carboxylic group, COOH acid, and we are getting the alcohol after the reduction. Okay, so you have understood the reduction process as well the oxidation process. So the next is, okay, the diisobutyl aluminium hydride, DIBALH, is a commonly available selective reducing agent. So you have learned another reducing agent, that is DIBALH. So when you will write, say you are writing any example of oxidizing reagent or reducing reagent, so you give the full name. It can selectively reduce esters and nitriles to corresponding aldehydes. So it reduces ester to aldehyde. The reaction is carried out in inert and moisture-free atmosphere. So ester to aldehyde. So here you can see the group I am showing. So it is your ester group, okay, COOR, and here you are getting the aldehyde group, CHO, that is the aldehyde group. The sodium borohydride, okay, that is also another reducing agent, is an ideal reducing agent for the reduction of aldehyde and ketones to give the corresponding alcohol. So if we like to make the alcohol from aldehyde, then we can use the sodium borohydride. So if we know the characteristics of all the reducing agent or oxidizing agent, that what is the role, then we can selectively use the reducing agent. Like say, when we require the aldehyde and ketone to give the corresponding alcohol, so we use the sodium borohydride. So unconjugated ketone and aldehyde are rapidly reduced, usually in preference to a conjugated carbonyl groups that may be present elsewhere in the molecules. The reactions are performed in polar solvents such as THA, tetrahydrofuran, CH2,4O, DME, dimethoxyethan, that is C4H10O2, hydroxyl solvent and water, but the ethanol is the solvent of choice. Okay, so ethanol is more preferable. So here we are getting the example. In presence of sodium borohydride, you can see that is the what it convert the aldehyde or ketone to alcohol. So I am showing you here the aldehyde and ketone to alcohol. Okay, so here you see COOH converted into the OH. Next is the Clemmensen reduction. Clemmensen reduction, what is it? Clemmensen reduction is a chemical reaction described as a reduction of ketones or aldehydes to alkane using zinc amalgam and hydrochloric acid. So it is the zinc amalgam and hydrochloric acid. In presence of this, the ketone or aldehyde will be converted into alkane. So let's look at the example. So here the ketone will be converted into alkane. Okay, And what we require, that is the zinc amalgam, and it is the zinc amalgam, and that is the HCl. So another example also given here. It is the zinc amalgam, and you are getting from the ketone to the aldehyde. Okay, so you have understood the Clemmensen reduction. Next is Wolff-Kishner reduction. In Wolff-Kishner reduction, the Wolff-Kishner reduction is an organic reaction used to convert an aldehyde or ketone to an alkane using hydrogen. So here also we convert the aldehyde or ketone, but in presence of hydrogen, we use the hydrogen. So this is the hydrogen, and also we require a base additionally, that is the KOH. So here you can see the ketone, and it will be converted into the alkane. Here also you can see the ketone group, and it is converted into the alkane. So the mechanism begins with the attack of hydrogen of the aldehyde or ketone for form an imine. Okay, so you have understood the both reduction process, Clemmensen reduction and Wolff-Kishner reduction. Now, if I summarize what you have learned today. In the organic reactions, you have learned today that what is reduction reaction, what is oxidation reduction. And you have learned that different examples of oxidizing reagent. You have learned that how oxidation takes place, like from the alkane to aldehyde to ketone to ester. So these things are you have learned that from alcohol to aldehyde to carboxylic acid. You have learned this part, that oxidation, and you have learned specifically Beer-Villiger oxidation. And in the reduction part, you also have learned the different reducing agent, and the which one is the weak reducing agent, which one is the strong reducing agent. Like if the reducing agent is very strong, so directly it can convert from ketone to alkane or alcohol. But if it is like weak reducing agent, so only one step it can do. And also you have learned the Wolff-Kishner reduction and Clemmensen reduction. Now let's check that how much you have learned. So I have given some MCQ, and here you see the first one is a weak reducing agent among the following is which one? Option A, option B, option C, option D. You check this, that is the LiAlH4, NaBH4, H2 or platinum, all are weak reducing agents. So already I have mentioned that which one is the weak reducing agent, that is sodium borohydrate, option B, NaBH4. A strong reducing agent among the following. The similar, if you know the name of the strong reducing agent and strong weak reducing agent, so you can answer both. So here the strong reducing agent among the following will be LiAlH4. Okay, so next, look at the next question. So what is the question number 3? The ketone when treated with zinc amalgam and HCl results in the formation of which one? Carboxylic acid or aldehyde or alkane, or remain unchanged. So just see here, if we use the zinc amalgam and HCl, what is the reaction called? So look here, it is the Clemmensen reduction. Okay, you got it. So it is the reduction of ketone and aldehyde to alkane. So by Clemmensen reaction, we get ultimately alkane. So you can answer very easily, that is alkane. Next, in Baeyer-Villiger oxidation, aldehyde and ketones are oxidized to acids or esters or both acids and esters. None of the above are true. So here you can remember that is ester. Okay, so you can answer all these MCQ question. Now let's look at the short answer type question. So here, the short answer type question, write the short note on Clemmensen reduction. So generally the short notes comes. Write short notes on Clemmensen reduction. So here you can give the zinc amalgam and the concentrated HCl. So we are getting propanol to, we are getting alkane. Okay, so from the ketone we are getting the alkane. So this is the ketone part and we are getting the alkane. Here is also in presence of zinc amalgam and concentrated HCl, we are getting alkane. Next question is the give example of each of weak and strong oxidizing agents. Okay, so here the strong oxidizing agents, you can give the example K2Cr2O7 or H2SO4, and the weak oxidizing agent. So here, let me show properly. The strong oxidizing agent K2Cr2O7, or you can see, you can write also KMnO4, H2SO4, and the weak oxidizing agents PCC, PDC, and CrO3. Now, write short note on Baeyer-Villiger oxidation. So this question came in 2019 to 20 odd sem. So here you already I have discussed, just write down with the example. Okay, next the question number 4. Mention the products and name of the following reaction. So this is the similar type of question written in different way, like it is not telling that tell about the Baeyer-Villiger oxidation or the Clemmensen reduction. It is not telling like this. They are giving the reagents, you have to write the products. So first you can identify very well, this one is the Baeyer-Villiger oxidation. And in the answer part, I have given the answer that will be product. And if you go in the lecture part, study material, where I have told you, so you will get the same thing. Next example, you can see here with the zinc amalgam and the HCl. So can you tell that which reaction it is? It is Clemmensen reduction. So here also the product are given, because you know it is it converts from the ketone to alkane. Ketone to alkane. Okay, so here you can see it is from ketone to alkane. Now the Wolff-Kishner reduction. Write short notes on Wolff-Kishner reduction. So here you can see that the similar thing already I have described. So I hope you can write that in presence of hydrogen, in the Wolff-Kishner reaction, in presence of hydrogen, the organic reaction, it is used, like it converts the aldehyde or ketone to an alkane. And here we use the hydrogen and also base material, that is KOH. Okay, so today up to this, I hope that you have understood very well the different oxidation and reduction process. That is the end of organic reactions. So if you have any doubt, you can communicate with me. And also we will discuss the question answer session. So thank you all. I am ending my session.